second condition, there is the limit of this function at E0 when it tends to E0, okay? And the third condition, limits of average, the value of given function equal to equal limits of this function at E0 equal f x0, okay? E0. The function is continuous at given point. And the second definition, the function y equal fx is continuous on open interval AB if only if it is continuous
at x point in a closed interval, in an open interval.
in this interval, yes, okay. And the next condition, y equal fx is continuous on closed interval from A to B if only is satisfied. The first average is continuous on open interval AB, and the second condition,
Lim fx
fx
x x to a
limits fx when it tends to a plus
x plus
equal
equal
fa.
fa.
This condition is satisfied, right? Continuous, right? And when it tends to b minus equal fb. Okay, this is beside that the given function is left continuous b. Left continuous at b. Okay. Okay. Have you any questions? Next. Okay. Derivatives. The first lessons, derivatives. Okay. Our lessons, we will consolidate the knowledge about the derivatives of function one variable, and by the end of this lesson, you will be able to understand about the derivatives concept and the meaning of derivative. For example, we use the derivative to find the slope of tangent line. Now, practice the derivatives calculation rules. Okay, now first of all, we talk about the average rate of change. Okay. So you see this picture, the red line is the graph of the function y equal fx. Okay, the fx represents the total number of switches produced. Okay, and so we have a first question. What is the average number of sweets produced per hour from 9 a.m. to 11 a.m.? 11. What is the average number? Please repeat it for me. Okay. What is the average number? How much change number of sweets produced? How much change number of sweets? Go. That means 64 minus
11
11
minus 9.
minus 9. Okay, we obtain this. This fraction is called the average number of sweets produced. Okay. And we have this 54 sweets minus 20 sweets equal the slope of PR. PR is line. Okay. So as you know, the P is has coordinates 120. Okay, and R has 364. Okay, 2 point. Okay, it is easy to find the equation. The slope of PR. Okay, easy to. We apply the formula. We apply the formula M is 1 y1 and N is 2 y2. So we imply the equation of M N is as from x minus x1 over x minus x1. I'm sorry. Y2 minus y1 equal x minus y1 over, I'm sorry, x2 minus x1 y2 minus y1. Okay. We multiply cross product. We obtain y minus y1 equal y2 minus y1 over x2 minus x1 times x minus x1. So we imply this is the equation of M and N. Okay. It is easy to find y2 minus y1 over x2 minus x1 is called the slope of this line, straight line. Okay. And for example, we find 64. This is 64 minus 20 over 3 minus 1. It is called the slope of PR. Slope of PR. Okay. In this case, we have what is the slope of this is A by A and B. So slope of AB is, can you read for the slope of AB?
Fx plus h minus f.
Fx plus h, yes, correct, yes, sir.
Minus f x
Over
x plus x. So
yes.
it's 8.
few minutes we obtain this. This plus h minus f is h. This ratio is the average rate of change. Okay, the average rate of change y for average with respect to x from x0 to x plus h. Okay, and we have this definition. The average rate of change of f with respect to x is also called the difference quotient. It is given by this formula. You write this formula. Geometrically, this the average rate of change is the slope of second, okay, second line. It is called the second. Okay, and if we take the limits of this question, we take the limits of fx plus 8 minus fx over x. I'm sorry, over 8 when 8 tend to 0. That means when 8 tend to 0, that means this point the B tend to A. Okay, so we imply the second is tend to the tangent line AT. Okay, that means the second tangent tend to tangent line. Okay. So we say another way is this limit is a instantaneous rate of change. Okay, so we write it. The first part definition. Let the function y for average the average rate of change of y, with respect to x. As a change from x1 to x2 is a ratio of the change in output to the change in input. Yeah. The first definition, the average rates of change. Now you solve for me this example. Let the function y for f hq find the average rate of change. It change from 1 to 3. The question A, we have a fx3 minus fx1 over 3 minus 1 equal
13.
3q minus 1 over 2 equal 13. And the second question, it changed from 2 to 3, f3 minus f2 over 3 minus 2 equal 3q minus 2q over 3 minus 2 equal
19.
19. Yes. Okay. It is the average rate of change. Okay. Now we have another definition. This when we did the average rate of change. Okay, and if we take the 8 tend to 0, 8 tend to 0, that means the Q1 move to the Q2, Q3, and it tend to B. Okay, so we imply second line. Second line P Q1 tend to PT. PT is a tangent line. Second line tend to tangent line. Okay, so we imply the slope of the second line tend to the slope of tangent line. We have this slope. Slope of tangent line. Slope of tangent line is the limits of the average rate of change. 8 tend to 0. Okay. And we have this. Now we want to use to indicate the rate of change at the given point. It is called the instantaneous rates of change. Now we have this definition. The derivatives of the function y for average at the point x0 is a slope of tangent line. Okay, yeah, this formula. You write its definition. If f prime x0 exists, then we say that f is a differentiable at x0. Differentiable. Okay. This is a derivative definition about the derivative at given point. We have another definition. We say that the function f is differentiable over open interval AB if it is differentiable at each point x0 in this interval. Are you right for me? This definition. Now, I give you an example. Use the definition to find f prime x1 where f is equal square root 3x plus 1 the definition to find f prime x, f prime 1. That means you find the derivatives of the given function at x. Number 1. Okay. Solution. We consider we have limits of f as 1 plus x minus f as 1 over x. I'm sorry. Fx equals square root 3x plus 1. F prime 1. Okay. And limit f as 1 plus x minus f1 over x when x tends to 0. Okay. In this case, we at x0 equal number 1. In this case, we apply. And equal limits of square root 3 times 1 plus x plus 1 minus square root of 4. Over 8 when 8 tends to 0 and equal limits of square root 3x plus 4 minus 2 over 8 when 8 tends to 0. Okay. Now you need to calculate this limit. This limit. This limit has form indeterminate form. Indeterminate form 0 over 0, 8 tends to 0 equals 0 over 0. Okay. We need to multiply both the numerator and denominator by conjugate expression. That means we multiply square root 3x plus 4. You write like this. Zero over 0 and equal limit square root 3x plus 4 minus 2 times square root 3x plus 4 plus 2 over 8 times square root 3x plus 4 plus 2. Okay. Square root of 3x plus 4 plus 2 is called the conjugate expression. Conjugate expression of the numerator. 3x over 8 times plus 2. Okay, when 8 tends to 0. So as you know, 8 tends to 0. That means the value of x approaches number 0, but it is not equal to 0. We can and when
3 over 4.
Okay, we conclude 3 over 4 is that given function. Derivative of given function at 1 equal 3 over 4. The method to find derivative of the given function at the given point by definitions. Okay. Now I give you another example. To evaluate f prime at 2 where fx equal q roots of pi x minus 2. Okay. Now you calculate f prime 1, f prime 2, fx equals q root. You remember that we need to use the definition by f prime. You mustn't use the formula, only use definition. We take the limits f at 2 plus x minus f at 2 over x when x can to 0 equal what number? Limits of q roots 5 2 plus x minus 2 minus one number f over x when x can to 0. This limit has formed 0 over 0. Okay. Okay, and so you write limits of q plus 5x plus what number? X minus 2 over 8. We multiply by both the numerator by and denominator by what expression? Conjugate of this expression equal square root q root of 5x plus x square minus plus q root 5x plus x times 2 plus 4 is 0. Okay, when it tends to 0, and we have limits of we apply the equality a q minus bq equal this, and it equal 5x plus x minus 2 power 3 over 8 times q 5x plus x square plus 2 q root 5x plus 8 plus 4. When 8 tends to 0, and we simplify this expression, this number, and equal limits of number 5 over q 5x plus x square plus etc. When 8 tends to 0, equal what number? It equal 5 over what number? When 8 tends to 0, the first term on the denominator tends to number 4, because the q root equal number 2 square equal number 4 equal, so we got 12 in here. We conclude that f prime at 2 equal 5 over 12. Okay. You get it? Have you any question? Have you any question?
No. No.
Now we move on to the second the derivatives calculation rule is derivatives calculation rules. The first, we have the constant derivative equal on y equals 0 and power rules. H power n derivative equal n times h power n minus 1. Okay, and 1 over h prime equal minus 1 over h square. Okay, square root of h derivatives equal square root of h derivative equal 1 over 2 square root of h. And the a power h times natural root of a. Okay, and the special case e power h derivative equal e power h lowercase base a of h derivatives equal 1 over h times natural root of a. Natural root of a. A special case natural root of h derivatives equal 1 over h. Okay, so you write this formula. And we have some so let's 0 plus v derivative the sum rule equal equals 0 prime plus b prime minus different rule. Okay, it's the same. A product rule 0 times v derivative equal product rule equal 0 prime times v plus 0 times v prime. Okay, quotient rule 0 over v derivatives equal quotient rule read for me 0 over v derivative equal 0 prime times v minus 0 times v prime over v square. Okay. The sum and different rule and product rule and quotient rule and chain rule. Now we have chain rule. Okay. Chain rule. Assume that z y is a function of z, where z is a function of x. Okay, and so we consider y is a function of x. It is called the composite function. composite function, and y prime x equal f prime u times u prime x. It is called the chain rule. Now, for example, so you have if we have a xq derivative equal what expression?
It
3
x over 2
3
over
square plus 2x power 3 derivative.
Is
For this question, you net this equation is a number equal 0, okay, and it equal we apply this formula. Equal number 3 times 0. You apply chain rule. 0 that means 3x square plus 2x power 2. This formula, the same meaning this formula, but we need to multiply by 0 prime. That means you multiply by 3x square plus 2x prime. This is a chain rule. Apply chain rule. Okay, and it equal what expression? Equal 3 times 3x square plus 2x square. I'm sorry. 2x, yes, times 6x plus 2. This is that. Okay, we apply chain rule. What does it mean, chain rule? Chain rule. Okay, chain rule. Now, you write for me this formula. U is a U is a z of x. Okay, u power n derivative equal what if what is equation? What is equation? N times u power n minus 1 times u prime. Okay, and 1 over u derivative equal and square root of u derivative equal a power u derivative equal e power u derivative equal and logarithm base a of u derivative and natural logarithm u. Now, can you read for me the second formula? 1 over u derivatives equal
minus 1 over u square and multiply 4
U prime. U prime is U prime. Okay, I mean U prime. I mean, and you write U prime over U square. Okay, now and continue. Next formula. Next formula. U prime over 2 square root of U. And Minh Anh, can you read for me? A vào U derivative equal Vũ Minh Anh. Cao Đức Bình.
I think it's U a power U by being pair.
Natural root of A.
So A yes by U.
U prime.
U prime.
Okay, and E vào U equal special case.
U is
E vào U times U prime. Natural root of E equal 1. Okay, and to last formula. Logarithm base A of U equals U prime over U times natural root of A and U prime over U. Okay, so you write for me these formulas. Now, example. Differentiate the following functions. The question A, fx equal eq minus 5x square plus x plus 3. And question B, fx or gx equal natural root of 3x minus 1 over 4x plus 2 plus 3. Okay. Well, differentiate, that means you find the same meaning, you find f prime x or g prime. Okay, the question A, fx equal x cube minus 5x square plus x plus 3. Okay, f prime x equal. Now can you read for me?
3
Yes. Okay.
3x square x
3
over
x
square
square
minus 10x
correct answer. Question B, gx equal natural list 3x minus 1 over 4x plus 3. Right. G prime x, we apply natural list of 0. Derivative equal 0 prime over 0. Write this formula. Equal in this case 0 equal 3x minus 1 over 4x plus 3 derivative over 3x minus 1 over 4x plus 3. Okay. It equal and we take the derivative of question. We apply 0 over v derivative 0 prime times v minus 0 v prime over v square. Okay. And
equal 3 time
v times
4x plus 3
plus 3
minus 4 time 3x minus 1
times 3x minus 1 over
over
4x plus 3 square times divided by this expression. That means we multiply by the reciprocal of this question equal
it
4x plus 3 over reciprocal 3x minus 1. Okay. It equal
it equal 13 over 4x plus 3 square
square. You simplify
3x minus 1
okay, this is that. Okay. Now you calculate for me another example. Question C, 8x equal e power 3x and 2x square plus x plus 1. that's true. And f prime x equal you apply the 0 times b derivative equals 0 prime times b plus 0 times b prime, and e vào 0 derivative equal e vào 0 times 0 prime. Okay, the first term we take the derivative of the first term equal 3 times e vào 3x 2x square plus x plus 1 plus e vào 3x times what expression? Second term derivatives equal
4x
4x.
plus 1.
Okay, and then you take the common factor outside. F prime x equal common factor 3x e vào 3x times what expression? 6x square 3 times 2x square equal plus
3x
3x plus 4x equal 7x plus 4x here and plus what number?
4.
4. Yes, it's zero. Okay. Okay, now we move on to the second part, higher order derivatives. Higher order derivatives. We consider the function given by this. What is the f prime? F prime equal f prime equal 6x over 5 minus 12x cubed plus 6x square minus 5. Okay, and so we f prime is a new function, and we continue take the derivative of f prime. I mean, in this case, f prime, then we take prime again equal what expression?
13.
30x power 4 minus 36x square plus 12x.
12.
This expression is called the second order derivatives of the given function. We did not f 2 prime x f 2 prime x. That means f prime x, then we take prime x again. Okay, it is called the second order derivatives. Okay. Similarly, you take the derivative again, we obtain f first order derivative f 2 prime x, then we prime again. Okay. We continue, we obtain the higher order derivatives. Okay, now we have this definition. The second order derivatives. And continue in this manner. We have now we have this f by x is the first order derivative, and f by x equal f by x, then we again is a second order derivative, and f 3 prime f 2 prime x, then we again, and third order derivative. And f n x equal f n minus 1 x, and we again, this is a n d n order. Okay, in this case n less than or equal 4. Okay. If we take the first order derivative or second order derivative or third derivative, we use comma or prime in here. Okay, we use this notation. But if n less than 4, example f for x, that means the fourth derivatives and phi is the fifth derivatives. Okay. Okay, but you need to distinguish between two notations. F for x different. F for x in here very different. F for x, that means fx power 4, and this is the 4 derivatives, very different. Okay. If we use the derivative, you need to add in the round bracket in here. Okay. Then this is the exercise. Okay. Now we move on to the next chapter. Chapter 3. Before we move on to the chapter 3, and you show for me some exercise. Now you show for me the exercise chapter 1. You open the main book. Exercise. Can 81, 82, 83. answer for me this example. 81. In New York City, taxi cabs charge passengers $2.5 for entering a cab, and then 0.4 for each 1/5 of mile. 1/5 mile, yes. So we have the cost function is defined by this formula, and you can draw this graph. The question is, using the graph of the taxi cab fare function, find each the following limits: 84, 81 everywhere. What's the number? Limits of CH when it tend to 0 minus 0. I'm sorry, 0 point. Zero point 2.5 minus equal what number?
2.90.
2.90. So 2.5, not 2.9, because CH equal 2.90 if it's less than 0 or less than or equal 0.2. 0.2. In this case, 0.25. So you have this 0.2 and this 0.25 and point here. This point belong to the interval from 0.2 to 0.4. It is what number? 3.30. It's 0. Okay. Do you agree?
Yes.
The continue. C limits, large limits at C, large limits at 0.25. It is all. Limits CH when it tend to 0.25 plus. Okay. In this case, the left limit equal to the right limit, so we imply there exists the limit to two-sided limit Cx when it tends to 0.25 equal 3 equal 3.30. This is right. Okay. Exercise 21, 81, about the 82. Limits, left limits at of CH at 0.2 equal what number? Left limits.
Two point nine.
2.9. Yes, correct answer. And what about the right limits? Right limits at 0.2.
3.3.
3.3. So in this case, we have the left limit and right limits are different. So we apply what is we apply? In this case, so we have the limits C is when h tend to 0.2 minus equal 2.9. But the limit C is when h tend to 0.2 plus equal 3.30. And they are different. So we imply does not exist the limit C when it tend to 0.2. Okay, so you see in this case, if it tend to 0.9.2 from left side, the value of given function tend to this number. But it tend to 0 from right side. The given function tend to this point. Okay, and two different points. We imply does not exist. Okay. Now we continue. The 84 and 85. Very well. The positive function, the cost of sending a last envelope by US first class mail 0.9 for the first out and 0.2 for each additional out. So you have that means the function pH 84 limits left limits of pH at 1 equal what number? limit it tend to number 1 from left side. The value of given function
0.9.
Yes, correct answer. And what about the right limit?
1.1.
1.1, yes. And so what about the two-sided limit? Ph at 1. What can you talk about this limit?
Not exist.
Does not exist. Okay, now similarly, it's just 85. Left limits of pH at 2. At number 2, left limit equal. You can see this graph, or you can see on this expression. Two equal what number?
1.3.
One, not 1.3. Left limits
1.1.
1.3. We continue to another part. This limit and continuity. 84. Not 48. 48. Right. This consider the function ch equal ch is minus 1 for x less than 2, and ch equal 2 equal 1 for x less than 2, less than or equal to. This function is called the piecewise function. It is called the piecewise function. Piecewise. So you're right. Piecewise function. Piecewise function. You're right. Piecewise functions. Okay. And the first question, you find the limits of f ch when it tends to 2 plus equal what number? 2 plus. That means it tends to number 2 from right side.
1.
Number 1 from right side equal number 1. And the second, left limits equal
Minus 1.
minus 1. And two side limits
Not exist.
not exist. Okay. And question D, CH2. CH2 equal the value of this function at number 2 equal what number? But 1. Okay, and is this C continuous up to Y or why not?
No.
C discontinuous up to because why?
It isn't continuous because left limit doesn't equal to right limit.
Yes, does not limit CX at 2 because have a answer the question C and continue. Question F is a C is continuous at 0.1.95.
Yes.
Yes, that's correct answer. Okay. And continue the another exercise 53. So you see 53 here is the function given by continuous at number 3. So the same meaning, you need to consider the continuity of the given function at number 3.
It is continuous.
Why?
Because left limit equals to right limit.
Okay. And what else? So you need to write limits. The first condition number 3 belongs to the domain of this function, and the second condition left limits h tend to 3 minus equal what number? Equal limits at the 1/3 h plus 4 when h tend to 3 minus equal what number? Number 5. Gx when h tend to 3 plus equal limits of 2x minus 1 when h tend to 3 plus equal number 5. Okay, and from this we imply there exists limits gx when it tend to number 3 equal 5. Okay, but it is not enough to conclude the given function is continuous. You need to determine that number 5 is g at 3. Okay, g at 3. We have this one, and we conclude that gx is continuous we use the definition to prove the given function is continuous at the given point. Okay. Okay. Now we have a subtract After short break, we continue move on to the next chapter. Okay, on remain you yourself, and the next lessons I will help you to solve on the difficult exercise. Okay, if you have any question, then you can let me know. Okay, now we have a short break about 15 minutes.